So looking at using the triangles again, but in this example, we're going to mix the two triangles, both number of moles concentration and volume and number of moles mass and GFM. So if we look at both the triangles, what do they have in common? You'll see quite clearly that they both have a number of moles in them. Now, in real life lab chemistry and in class, we often need to look at the mass of something that we need to make a solution of a certain volume and concentration, or we maybe need to find the concentration of something, knowing the mass and the volume that was being added. Those are examples. It could also be that we know the mass and the concentration and we want to know the volume. But because mass, concentration and volume aren't all in the one triangle, we have to use the two triangles and this link between the number of moles to work out these questions. So here's an example. Lily wants to make a 500 centimetre cubed standard solution of sodium hydroxide with a concentration of 0.5 moles per litre. What mass of sodium hydroxide does Lily need? So what do we know? We know that the concentration is 0.5. We know the volume is going to be 0.5 because 500 centimetres cubed is 0.5 litres, which is what we want to know. What we want to work out is the mass required for this. Now, we always know the GFM. You might have to work it out. Most likely it will be given to you in the question. In this case, it's 40 grams per mole for sodium hydroxide, so we know the GFM. So we need the number of moles to be able to work out this mass. We can't work it out without that. This number of moles, the number of moles in the solution, is the same as the number of moles in this equation. So we can work out the number of moles here and use it here. So step one then in this calculation is to find the number of moles. So the number of moles is the concentration times the volume, 0.05 times 0.5, which is going to give you 0.25 moles. So 0.25 moles here, we've got our mass as number of moles times GFM. So to find the mass, we're doing number of moles times GFM, sub them in, 0.25 times 40, and we get 10 grams. So if Lily wanted to make this solution, she would have to dissolve 10 grams of solid sodium hydroxide in the standard flask to make it. Another example. Caleb dissolved 1.25 grams of magnesium chloride, GFM 95.3 grams per mole, in 0.25 litres of water. What is the concentration of the resulting solution? So this time, we know the mass and we know the GFM and we know the volume. We want to find the concentration, and again we can do that because this number of moles and this number of moles are the same. So step one here, you've got find the number of moles. Number of moles is mass divided by GFM. So from our question we've got 1.25 and 95.3, and that gives us 0.03 moles. We can then use the 0.03 moles in this triangle to work out the concentration. So find the concentration. C is N over V. So we've got 0.03 divided by the original volume, 0.25, and we get 0.12 moles per litre.